Assalamualaikum warahmatullahi wabarakatuh and good evening. Today, our group will present the title of amplitude modulation. This our team member, Nur Azilham bin Nur Azmi, Hari Hakimi bin Muhammad Hafizi, Muhammad Idami Azman, and Ahmad Fauzan bin Azir. First, the introduction. Modulation is the process of varying one or more properties of a periodic waveform, known as the carrier signal, with a spread signal known as the modulation signal, which typically contains information to be transmitted. Number one, an audio signal representing sound from a microphone. Number two, a video signal representing moving image from a video camera. Number three, a digital signal representing a sequence of binary numbers. Next, the carrier frequency is higher than the modulation signal frequency. First, several carrier signals, each modulated with a separate television channel, are carried to customers via a single cable. Amplitude modulation, AM, in which the modulation signal changes the amplitude strength of the carrier wave, and frequency modulation, FM, in which the modulation signal changes the frequency of the carrier wave. Next, modulation. Modulation is the technique of encoding information in a broadcast signal, transforming data in radio wave by adding information to an electrical or optical carrier signal. A carrier signal has a consistent height or amplitude and frequency, whereas the modulation is the process of extracting information from a transmitted signal. Number one, amplitude modulation, AM. To reflect the data being added to the signal, the height of the signal carrier is altered. Number two, frequency modulation, FM. To reflect the frequency of the data, the carrier waveform's frequency is altered. Number three, polarization modulation. To reflect transmitted data, the angle of rotation of an optical carrier signal is adjusted. Number four, pulse code modulation. A digital carrier signal is modulated using an analog signal that has been sampled. Number five, phase modulation, PM. The carrier waveform's phase is changed to match variations in data frequency. In PM, the frequency remains constant while the phase changes in relation to the base carrier frequency. It is comparable to FM. Okay, next I will pass to my member.
Assalamualaikum. My name is Ahmad Fauzan. For this part, we discuss amplitude modulation, AM. First, amplitude modulation definition is given as a type of modulation where the amplitude of the carrier wave is varied in some proportion with respect to the modulation data or the signal. For the mechanism, amplitude modulation is used. There is a variation in amplitude of the carrier. The voltage or the power level of the information signal change the amplitude of the carrier. In AM, the carrier does not vary in amplitude. The modulation data is in the form of signal component consisting of frequency either higher or lower than that of the carrier. The sideband power is responsible for the variation in overall amplitude of the signal. The AM technique is a totally different from frequency modulation and phase modulation, where the frequency of the carrier signal is varied in the first case, in the second one, and the phase is varied respectively. Okay.
Okay, I will explain about the amplitude modulation circuit. Okay, this is our circuit for this project. Okay, we can see this IS is to information signal, and the CS is carrier signal. Okay, I will present you the live circuit. Okay, as you can see, this is the information circuit, and this is a carrier circuit. Okay, and this is the circuit that make the modulation, and this is the oscilloscope that we can see the signal with. Okay, this I connect to the channel A for the information signal, and this I connect to the channel B for the carrier signal, and the last one, the channel C for the modulation wave. Okay, I will run the circuit. Okay, you can see the yellow wave is the information, blue for the carrier, and the fish color for the modulation. Okay. When we range, when we increase the level of the information, and the information and the modulation signal will change also, but the original form for the modulation is distortion. So as we know, the frequency for the information, the low frequency, but the carrier must the high frequency from the information circuit. Next slide. Okay, this is I print out this signal from the oscilloscope. Channel 1, channel 2, and channel 3. Okay, next.
Okay, for the discussion, I'll be presenting information signal is the network saved or obtained from a computer. As a result, wireless network allows data to be transferred from one computer to another. Email messages, files, online pages, video, music, and voice interaction are all examples of data. Carrier signal. A waveform that has been modulated with an information-bearing signal is in order to communicate information. This carrier wave is typically significantly higher in frequency than the incoming signal. And lastly, modulating signal. The modulating signal will modulate the carrier signal, allowing the information contained in the modulating signal to be efficiently transmitted over free space by an antenna at radio frequency. So for the conclusion, we investigated the principle of amplitude modulation and its application to various systems, the AM and its derivative. Scheme essentially involve the control shifting of the signal spectrum to various points along the frequency scale. The modulation properties can be utilized to generate amplitude modulated waveforms and then demodulated them. Because such waveforms lack a discrete carrier frequency, they are referred to as double sideband. A carrier frequency is added to help in waveform demodulation. An envelope detector can correctly demodulate the waveform if the additional value, carrier amplitude, is large. Commercial AM radio uses this principle. It has considerable deficiencies in dynamic range and noise immunity. To enhance things, we need to utilize a whole different kind of FM modulation, the technique of detecting or collecting information from a modulating signal is known as AM demodulation or detection. That's all from us. Thank you.